I wanted to do a quick review of some basic stuff with the exponents that we've done so far. So the first four are all multiplying with exponents, and I want to go ahead and highlight all of the constants in the problems to make sure that you realize that for those, you still treat them like regular numbers. They do not apply to these rules of exponents. So I'm going to start with that and go ahead and say 3 times 4, which is 12, and 3 times 2, which is 6, 3 times 4 again, 12, and then 4 times, I forgot this one, sorry, 4 times 4 is 16. So now I'm going to go back and look at the variables. So I'm going to start with the m's. I have m to the second power here and m to the fourth power here. So that's going to be m to the sixth power because you're adding the exponents. And then the only n we have left is this one, n to the fourth. So there's that one. Here, let's look at the x's. X squared, x to the fourth. That's x to the sixth. And then y to the fourth is y to the eighth. Again, we are adding the exponents. Number 3, for the u's, this one doesn't have an exponent, so that exponent is considered to be a 1. And then u squared, so that added together would make 3. And then here's the only v, so that's another 3. Then for the x's here, there's 3 here and 4 here. And imagine if you listed out 3 x's and then 4 x's. 1, 2, 3, 4, 5, 6, 7, 7 x's. So that's another way to look at it. And then for the y's, you only have this one, y to the third. So that's all multiplying. So when you're multiplying, you add the exponents. Then we have dividing for the next 4. Again, I'm going to start with the coefficients here and here. Here's 1, here and here, here and here. And you actually treat those like regular numbers, fractions, however you want to look at it. So here we have 2 over 4, which can be simplified to 1/2. So that part's done. This one doesn't have anything but a 4, so we're going to leave the 4 there. This one is 3 over 2. That cannot be simplified. We don't want to change it to a mixed number, so we're going to leave it. And then 2 over 2 actually cancels each other out. So those are gone. So now let's look at the exponents. So we're looking at the x's first here, and there's only this one. So it's on the top, so it gets to stay on the top. Now let's look at your y's. And the rule here is to subtract them. But here's what I like to do. I like to ask myself, if these 2 y's were in a contest to see who has more of something, the bottom y would win. So the bottom y would win. So that's where the y is going to stay, and it would win by 1. So it would be y to the first. So another way to write this, more simplified, you usually don't need this 1 or this 1. So it would be x cubed over 2y. To simplify it. Over here, you have your a's. So I'm going to circle them first. Here's 3 a's, and this doesn't have an exponent, so that's considered to be a 1. So who would win, the top one or the bottom one? The top one. So that's where our a is going to go, and it would win by 2. Look at your b's. Who would win, the top or the bottom? The bottom. So that's where the b is going to go. How many would it win by? 2. And that one is done. Over here, we have our x's. There's 1 x on top because there's no exponent, so we're going to make those both a 1. So which x would win, the top or the bottom? Obviously, it's the bottom by 1. And the y's, the bottom would also win by 2. So I could rewrite it as 3 over 2xy squared. We do not need that 1 back at the end. Over here, our 2's canceled. So first we'll look at the u. There's only 1 u, so it's going to stay on the bottom. Now let's look at the v's. Here's a 1 and a 3. Who's going to win? The bottom. So the bottom's going to win by 2. And now there's nothing left on top. So when that happens and there's nothing left, we put a 1. And that will happen quite frequently. So those are all dividing. So basically you're subtracting the exponents, but the whole looking at who wins, the top or the bottom, is probably easier. So next is what you did with the product rule, or I like to call it power to power. So I'm going to first go through, like I have been doing, and highlight the constants because we treat those like regular numbers first. So I'm actually going to do 4 squared, which is 16. And this is the part that a lot of people forget to do. They forget to actually apply that squared to the whole number as well. So this one would be 3 cubed. Well, 3 times 3 is 9, times another 3 is 27. 2 cubed, 2 times 2 is 4, times 2 is 8. And then this one doesn't have a constant, so we're ready to start with our exponents. So remember, anytime there's not an exponent, it's considered to be a 1. So that's a 1 and that's a 1. So our rule for powers to powers is multiply. So we're not adding like we did in the first 4. We're multiplying. 2 times 1 would be 2. And 1 times 2 again would be 2. So that's your final answer for that one, power to power. Over here, for m, it would be 2 times 3, which is 6. And for the n, 4 times 3, which is 12. Back down here, for the m's, 4 times 3, 12. And for the n, 2 times 3, 6. And finally here, 2 times 4 is 8, and another 2 times 4 is 8. So I hope this helps with rules of exponents, multiplying, dividing, and the power rule.